Hey guys, welcome to this session. Our topic is magnetism. So far in our past videos, we saw the concept of magnetism. We discussed the magnetization versus the demagnetization. We saw the various types of magnets. So today, let's specifically discuss the angle of inclination or the angle of dip and the angles of declination. So we'll start with the angle of inclination. In our past video, we also discussed the Earth's magnetic field. So all these angles are the ones that can be related to the Earth's magnetic field. So we'll start with the concept of angle of inclination, or just the angle of dip. We can also call it like that. The angle of dip or the angle of inclination is the angle between the direction of the Earth's magnetic flux and the horizontal. So as you can see here, it's just a diagram that shows this angle of inclination. As you can see here, this is a magnetic needle. It's a kind of like a compass that shows the direction. Now the angle HOM, H is here, this is the horizontal plane, and M, this is the magnetic axis, and the O, this is like the center. So the angle HOM between the horizontal plane HO and the axis of the freely suspended magnetic needle, that is MO, is the angle for dip or angle for inclination. So this angle here that is found between the horizontal plane and the magnetic axis is the angle of dip. So we get it there, the definition, that is the angle between the direction of the Earth's magnetic flux and the horizontal plane. I hope it's clear. So let's move on to the measurement of the angle of dip or the angle of inclination. The angle of dip is not constant over the Earth's surface. It just varies from place to place. Now, this kind of a difference or variance is brought about by the Earth's magnetic field direction at a point on the Earth's surface. So the difference of the angle of dip within various places is just caused by the Earth's magnetic field direction at a given point on the Earth's surface. The easiest way to measure the angle of dip or the angle of inclination is using a thin iron rod. So a thin iron rod is the easiest way where you can use this just to measure the angle of dip or the angle of inclination. The load first is the one that is suspended by a length of a thread such that it balances horizontal. This is the iron rod. Then, without disturbing the position of the attachment, the rod is magnetized by bringing close a bar magnet or a bar magnet and touching it. Now, only suspending the rod will dip with its north pole pointing downwards, as shown in the diagram above, which we have seen that is the one that is illustrating the angle of dip. So using a protector, the angle between the axis of the load and the horizontal can be measured. So from there, you can use the protector and determine the angle of dip by using a protector. So I hope it's clear. Moving on, let's see the angle of declination. Now, this is just the angle between the magnetic meridian and the geographical meridian. So it's totally different from the angle of dip or the angle of inclination. The angle of declination, it varies from place to place all over the world. It's the same goes to the angle of dip. The maps shows the declination at different points of the world. So you can simply identify the angle of this declination simply at looking the maps showing the various positions of the world. Now let's see the various applications of the Earth's magnetic field. As far in our past video, we discussed this, the Earth's magnetic field. So here we're going to see the application of this magnetic field. Why do we need it? The Earth's magnetic field is used to indicate the poles of the unknown magnets. So simply if you have some kinds of magnets and you don't know which which kind of poles is either maybe north or south pole. You can simply use the Earth's magnetic field to identify the given poles of the unknown magnet. The second one, that the Earth's magnetic field is the one that is used to enable the use of the magnetic needle. So without the Earth's magnetic field, you can't simply use the magnetic needle that you can use it to locate the various places on the Earth's surface. So the Earth's magnetic field is very essential in trying to use the magnetic needle, simply maybe as to locate the various areas or places on the Earth's surface. So I hope it's clear, guys. Thank you for listening. So briefly we've discussed the angle of inclination and the angle of declination. I hope they were clear, and we've later on seen the various applications of the Earth's magnetic field. Thank you.